In this video, we'll be going over integrals that involve logarithmic functions. So the key thing to remember with logarithmic functions is if we have the integral of x to the negative 1 dx, this is equal to ln of the absolute value of x plus c. So if we can get to something in this form, either by U-Substitution or just regular algebraic manipulation, that'll result in ln of the absolute value of x. So that's kind of the main idea with what we're going to see here in this video. So let's look at this example. We have the integral of 11 over 8 ln of x raised to the fourth dx. So before we do any calculus, before we start looking at what the integral is going to be, let's take out the 11 over 8. We're left with 1 over ln of x to the fourth dx. And I'm looking at my notes. I forgot to put an x in here, so we want an x in the denominator also. Okay, so we have 11 over 8, the integral of 1 over x ln of x to the fourth dx. So we're going to do a U-substitution here. We're going to say, let's let u be equal to ln of x, and then the derivative of that, we're going to have 1 over x dx. So looking at how we can substitute, well, this right here is 1 over x, and then we have the dx. So 11 over 8, the integral of, so that 1 over x dx is going to be du, and then I have u in the denominator raised to the fourth power. We're going to apply the power rule here, so instead of writing 1 over u to the fourth, we're going to say u to the negative fourth du, and this will equal 1 over 8 u negative 4, raise that power by 1, so it'll be to the negative third, divided by negative 3, plus c. So what we get is 11/8 u, which is ln of x, raised to the negative 3, divided by negative 3, and we're multiplying here. So I'm going to have 11 in the numerator, divided by negative 24 ln of x, raised to the third power, plus c. Okay, so the key thing here was seeing that we had 1 over x, ln of x to the fourth, but that 1 over x is the derivative of the natural log function. So it's key to be able to recognize that. Let's do two other examples. So here we have the integral of 7 raised to the ln of x divided by 5x. So we'll factor out the 5 here, and we'll factor that out as 1/5. I can't factor out the 7 because that's the base of this exponential function. Okay, so a similar idea to what we had last time. Let's say there's a times 1 in the numerator. This 1 over x is the derivative of ln of x. So we're going to let u be equal to ln of x again. So du is equal to 1 over x dx. So when we substitute, we're going to have 1/5 the integral of, well, 1 over x dx is going to be du, and then I'm going to have 7 raised to the u power. Okay, so what we saw in an earlier video was that when we have a constant raised to a function and we want to integrate that, we're going to say 7 to the u divided by ln of whatever that base is, which is 7, plus c. And then resubstituting in the u, we're going to have 1 times 7 raised to the ln of x divided by 5 ln of 7 plus c. And our last example here, we have 7x squared sine of x cubed dx all over 8.5 cosine of x cubed. What I'm going to do again is I'm going to factor out those coefficients. So I have x squared sine of x cubed divided by cosine of x cubed dx. So sine and cosine are derivatives of each other, so it makes sense that we would have one of those be set to u. So let's let u equal cosine of x cubed. When we take the derivative of that, well, the derivative of cosine is negative sine of x cubed times the derivative of the inside function, so that's 3x squared. So looking at what we have a sine x cubed, which is what we have right here, and then we have x squared, which I have right here, but I have a little bit of extra information on the right hand side of this du equation. So what I'm going to do is I'm going to divide both sides by -3. So we'll have du over -3. That will leave us with positive sine of x cubed times x squared. So that is exactly what we have in the numerator. Oh, and we need a dx on both of these. So that is exactly what we have in the numerator. So when I substitute in, the denominator is going to be u, and then the numerator will be du over -3, but I can put the -3 downstairs like this. And then I'll bring that -3 out and multiply it by the 8.5. So -3 times 8.5 is -25.5, the integral of du over u. And again, we have 1 over u, which is the ln of u. So I have 7 over -25.5 ln of u plus c. And then u here is cosine of x cubed. So -7 over 25.5 ln of cosine of x cubed plus c, and that is our final answer. And I actually want to do one last example where we have a definite integral. So we have the integral from 1 to 2 of 1 plus 2x plus x squared all over 3x plus 3x squared plus x cubed dx. So everything in the denominator, well, the denominator is degree 3 because that polynomial, because we have x cubed here. The numerator is x squared. So let's see what happens when we do a U-substitution, setting u as the denominator. So we take the derivative of this, we're going to have 3 plus 6x plus 3x squared dx. Now that's not quite what we have in the numerator, but if we factor out a 3, we do get exactly what we have in the numerator. So divide both sides by 3, left with 1 plus 2x plus x squared dx. So we can set the numerator, or I guess we'll set the denominator to be u here, and then the numerator will be du over 3. Actually, don't write those limits of integration just yet, because when we do a U-substitution on a definite integral, we need to change the limits of integration. So initially x was equal to 2, or I should say x is equal to 1, and then x is equal to 2. But now that we're writing everything in terms of u, in other words, our variable of integration is u, we need to change the limits from an x value to a u value. So what we do is, I'm going to say when u is 1, what happens when we plug that in right here? Actually, we should say that when x is 1, what does u become? So I have 3 times 1 is 3, 3 times 1 squared is 3, 3 cubed is 1. So when x is 1, I get a u value of 7. And then when x is 2, what u value do I get? Well, I get 3 times 2 is 6, plus 3 times 2 squared, 3 times 4 is 12, plus 2 to the third is 8, so we get 26. Whoops, we get 26 here. Having trouble writing on the edge of the page. All right, so our new limits of integration are going to be from 7 to 26. And then I'm going to write this 3 out here as 1/3. So our new definite integral is 1/3 from 7 to 27 of du over u. So we get 1/3 of, that's the ln of u, and we're integrating that from 7 to 27. Okay, so what I'll do first is enter whatever we had for u here. I mean, this is in terms of, these are limits for u. So this will be 1/3 ln of 27 minus 1/3 ln of 7. And we could write it like that, or we could factor out the 1/3 and say ln of, I don't need the absolute value on the 27 anymore because 27 is positive. Okay, so we could write it like this. And if we really want to get fancy and impress your teacher, we could say ln of 27 over 7, and that is just using the quotient rule for logarithms.